Hello students, in previous lecture we have studied about the division of polynomials and the examples which is based on division of polynomials we have solved from the practice set 3.2, and we can solve the examples of division of polynomials by one of the simple method, that is synthetic division method. And today we are going to solve few examples of division of polynomial by synthetic division method. Synthetic division method of division of polynomials is one of the simplest method, but here if the divisor is in the form of, here if divisor is in the form of x plus a or x minus a, then focus here, the if divisor is in the form of x plus a or x minus a, for example if divisor is x plus 2 or x minus 4 like that, then or we can solve the examples of division of polynomials by synthetic division method. Then we will solve few examples of synthetic division method. Then first of all, see here we have to solve one of the example of division of polynomial by synthetic division method. Then see here the example which is given here, 2y raised to 4 minus 3y cube plus 5y minus 4, and that polynomial is divisible by y minus 1. Then see here y minus 1 is a divisor and which is in the form of x minus a. See here that is in the form of x minus a. Then first of all we have to write dividend, that is in index form. Then while solving the examples by synthetic division method of polynomials, then first of all we have to write the dividend in the index form. Therefore see here the degree of highest degree of y variable in this polynomial is y raised to, that is 4. Therefore first of all we have to write 2y raised to 4 minus 3y cube. Then quadratic term is not there, therefore we have to write 0y square. Then we have to write plus 5y, then minus 4y raised to 0. Then see here 4, 3, 2, 1, 0. All terms are there. Therefore, then we have to write the coefficient form of that dividend. Then see here coefficient form of that polynomial. Then 2 minus 3, 0, 5 minus 4. That is the coefficient form of that polynomial given in the dividend. Then here we have to write divisor which is in the form of x minus a, that is here y minus 1 is there. Then first of all we have to find out the value of a. Value of a means, see here y minus 1 is there and here constant term is minus 1. Therefore opposite of minus 1, that is plus 1 or 1. Here a is equals to 1. Then we have to solve the example using those concepts. Then first of all we have to write the coefficient form of that polynomial of dividend here, that is 2 minus 3 0 5 and minus 4. Then see here, the value of a is plus 1 or 1, that is written here. Then first of all we have to write that first coefficient of dividend polynomial is as it is here. Then we have to multiply that 2 by 1. 1, that is the value of a, that is 1. It is multiplied by 1. Therefore 2 into 1, that is 2 into 1. We get here 2. Therefore that is written here. Therefore minus 3 plus 2. See here, minus 3 plus 2. We get minus 1. Therefore here we get minus 1. Then again that minus 1 is multiplied by 1. Therefore here we get minus 1 into 1, that is minus 1. And again see here, 0 minus 1, that is minus 1. Therefore we have to write 0 minus 1, that is minus 1. Then again we have to multiply that minus 1 by 1. Therefore here we have to write minus 1 below that coefficient in the fourth term. Therefore 5 minus 1, that is 4. Then we have to multiply that 4 by again 1. Then we get 4 into 1, that is plus 4. Minus 4 plus 4, here we get 0. The set of number, that is 2 minus 1, 4, 0. Out of that 0, the last number, which is a remainder. Remaining terms we have to write here, 2 minus 1, 4. That means here we get the coefficient form of, we have to convert that coefficient form into index form and then it into standard form. Therefore here we get quotient in index form. See here, 2 minus 1, 4. There are total 4 digits are there. Therefore degree is, highest degree is 3. We have to make sure that there is variable is y. Therefore we have to write here y variable. Therefore 2y cube, because there are 4 digits in the coefficient form of that polynomial. Therefore 2y cube minus 1y square minus 1y plus 4. That means here 2y cube minus y square minus y plus 4. That means here we get the quotient of this example in standard form. Therefore here we get the quotient, that is 2y cube minus y square minus y plus 4. That is the quotient. And here the remainder we get here. The remainder we got here, that is 0. That is the synthetic division method of division of polynomials. That is one of the simplest method of division of polynomial. And see here, if remainder is 0, then the divisor is the factor of that dividend. That means here y minus 1 is a factor of that polynomial, that is 2y raised to 4 minus 3y cube plus 5y minus 4. That is the synthetic division method of solving examples of division of polynomials. Then we will solve few more examples from practice set 3.3. We will solve the example number 1, which is given here, x raised to 4 plus 2x cube plus 3x square plus 4x plus 5, and here that polynomial which is divided by x plus 2. Then here divisor is x plus 2, which is in the form of x plus a, and therefore first of all we have to write dividend, that is here x raised to 4 plus 2x cube plus 3x square plus 4x plus 5. Then see here 1x raised to 4 plus cubic term is there 2x cube plus 3x square plus 4x plus 5x raised to 0. Then see here 4 degrees are 4, 3, 2, 1 and 0. All terms are there. Therefore, first of all, we have to write the coefficient form. That is 1, 2, 3, 4 and 5. That is the coefficient form of dividend. And here divisor, which is given, that is x plus 2. We can solve this example by synthetic division method. Therefore, here plus 2 is there. Here we get a is equals to minus 2. Then, first of all, you have to write the coefficient form of dividend polynomial given in the dividend. That is 1, 2, 3, 4 and 5. And here the value of a, that is minus 2, which is written here. Then we have to write the first coefficient as it is below to this line. There are 3 rows are there. First row, second row will be there, and third row from which we can get the quotient and remainder. Then 1 is multiplied by minus 2. Therefore here 1 into minus 2, that is minus 2. Therefore 2 minus 2, 0 is there. Again see here 0 is multiplied by minus 2. Therefore here we get 0. And here 3 plus 0, 3. Then 3 into minus 2, that is minus 6. Then 4 minus 6, that is minus 2 is there. Then minus 2 into minus 2, that is minus minus plus, and 2 into 2, 4. Plus 4, plus 5 and plus 4, here we get 9. Then see here, we get the set of those digits in which the last digit is the remainder. Therefore, here we get the remainder, that is 9. Therefore, again here we get the quotient which is in coefficient form. We have to write it in coefficient form. First 1, 0, 3, minus 2. Then we can convert this coefficient form of quotient into standard form. Then see here, there are total 4 digits are there. Therefore, degree of that polynomial which obtain in the quotient, that is 3. And here variable which is used is x. Therefore, we should write the quotient in x variable. If you write the quotient by taking any other variable, then it is wrong. Then see here, 1x cube, because there are 4 digits are there, plus 0x square plus 3x raised to 1 minus 2x raised to 0. Therefore, here we have to write the standard form of that quotient. Therefore, here we get quotient in standard form, that is x cube. We have to avoid to write this term, plus 3x minus 2. That is the quotient of this example. And here we get remainder, that is 9. Then we can tally whether our example is correct or wrong by using the value in this formula, that is dividend is equals to divisor into quotient plus remainder. Then see here, dividend here, that is therefore x raised to 4 plus 2x cube plus 3x square plus 4x plus 5 is equals to divisor, which is given here, that is x plus 2, and here we get quotient. Here we got quotient, that is x cube plus 3x minus 2 plus remainder, that is 9. Then we have to multiply this polynomial by x plus 2. And see here, first of all we have to multiply it by that x to all bracket, then x into x cube, that is x raised to 4, plus x into 3x, that is 3x square, plus minus 2 into x, that is minus 2x. Then we have to multiply this bracket by 2. Therefore, here we get plus 2x cube, 3x into 2, that is plus 6x, 2 into minus 2, that is minus 4. And here plus 9 is there. Then see here, we get, that is x raised to 4 plus 3x square is term is there, as well as cubic term is there. Then first of all we have to write cubic term, that is 2x cube plus 2x cube. Then we have to write the quadratic term, that is 3x square, then minus 2x and plus 6x. All of you have done, or all of you have solved the examples of addition and subtraction of polynomials. Therefore, minus 2x plus 6x, that is 4x. Minus 4 plus 9, that is plus 5. Here we get the RHS, which is equals to the LHS. See here, make sure that LHS is equals to RHS here. X raised to 4 plus 2x cube plus 3x square plus 4x plus 5. Therefore, here the example which we have solved is correct. Then the examples of synthetic division methods of division of polynomials are given in the practice set 3.3. We have to solve one more example from practice set 3.3, that is here, y cube minus 216, which is divided by, that is y minus 6. Then here dividend, which is given in the y variable, that is polynomial in y variable, that is y cube minus 216. Therefore, we have to write this in index form. Therefore, see here, degree of that y is 3. Therefore, we have to write 1y cube. My plus quadratic term is absent. Therefore, 0y square. Plus linear term is not there. Therefore, 0y. Then, we have to write minus 216 y raised to 0. Then, see here, 3, 2, 1, 0. All terms are there. Therefore, we have to write coefficient form of dividend, that is 1, 0, 0, minus 216. Then divisor which is given here, that is y minus 6. Therefore, here we get the value of a, that is plus 6, that is opposite of minus 6, plus 6. And then we get quotient and remainder after solving this example by synthetic division method. Then we have to write the coefficients of polynomial given in the dividend, that is 1, 0, 0, minus 216, which is divisible by, or we have to divide it by 6. Then first of all we have to write 1, then 1 is multiplied by 6, therefore we get here 6, 0 plus 6, that is 6 is there, 6 into 6, 36, therefore 0 plus 36, here we get 36. Then we have to multiply 36 by 6, therefore here we get 216, that is plus 216, minus 216 plus 216, here we get 0. That means that is the remainder. 0 is the remainder. And here we have to write the quotient in standard form using those digits. Then here coefficient form of quotient, that is 1, 6 and 36. Therefore here the index form of quotient, here we get 1, here y variable is used here, therefore we have to write y variable, 1y square plus 6y plus 36y raised to 0. See here 210. Therefore we have to write y square plus 6y plus 36. That means here we get the quotient, here we got the quotient, that is y square plus 6y plus 36. Then here remainder is 0, therefore y minus 6 is a factor of dividend, that is y cube minus 216. That is all about the synthetic division method. That is the one of the simplest method of division of polynomials. Then see here, we will solve the few examples which is depends upon the values of polynomials. Then see here, value of polynomial. Value of polynomial means here if px is a polynomial, px is a polynomial in x variable, and here if x is equals to a, then therefore pa is a value of given polynomial, value of given polynomial, that is polynomial in x variable. Then see here, we can use this concept to solve the examples which is based on getting the value of polynomials. Then see here, if x plus 2, that polynomial is given here, and if we put the value of x, if here x is equals to 7, then here we have to put the value of that x here, 7 plus 2. Therefore here we get the value, that is 9. Therefore 9 is a value of polynomial, that is x plus 2. That means 9 is a value of that polynomial x plus 2. Then there are few examples which is given in the practice set 3.4. Then see here, the question which is given here, that is examples which is given here, that is find the value of given polynomials. Then one of the example which is given here, that is see here, px is a polynomial which is given here, that is 2x square minus 3x plus 5, that polynomial is given here. And here if x is equals to 2 is given here, then find out the value of that given polynomial for x is equals to 2. Then we have to find the value for value of that polynomial for x is equals to 2. Therefore here p2 is a value of that polynomial. Therefore here putting the value of x here in this polynomial, 2 into 2 square minus 3 into here 2 plus 5. Then we have to simplify this, then we get the value of polynomial. Therefore 2 into 2 square, that is 2 into 4, minus 3 into 2, that is minus 6, plus 5, and here 4 into 2, that is 8 minus 6 plus 5. Then see here 8 minus 6, that is 2 plus 5. Therefore here we get 2 plus 5, that is 7. That is the value of this polynomial is 7. Then we can solve one more example, that is find the value of polynomial, that is px, which is given here, x square minus 5x plus 5 for x is equals to 0. Therefore we have to find the value of polynomial, that is p0 is the value of that given polynomial. Therefore we have to put the value of x, that is 0 square minus 5 into 0 plus 5. Then 0 square 0 minus 5 into 0 0 plus 5. Therefore here we get p0 means the value of this polynomial, that is 0 minus 0 0 plus 5, that is 5. Therefore here 5 is the value of that polynomial, that is x square minus 5x plus 5 for x is equals to 0. Then if we put the another value for x in this equation, then we will get the another value of polynomial for that given value of x. Then one more example which is given here, that is see here, question number 2, p y is a polynomial which is given here, y square minus 3 root 2y plus 1. and here we have to find the value of polynomial py for y is equals to 3 root 2. Therefore, we get the value of that polynomial, that is p 3 root 2 is the value of that polynomial, and therefore we have to put the value of y in this polynomial. Therefore, here y square is there, therefore 3 root 2 bracket square minus 3 root 2 into y, the value of y is 3 root 2 and plus 1 is there. Then see here, the value of polynomial for y is equals to 3 root 2 is, see here, 3 root 2 bracket square. Therefore here 3 square root 2 square minus, see here, 3 root 2 into 3 root 2, that means 3 into 3, 9, root 2 into root 2, that is root 4, plus 1. Then see here, 3 square 9 into root 2 square, that is here we get 2, minus 9 into root 4 means 2, plus 1. Therefore here we get, that is 9 into 2, 18, minus 9 into 2, 18, plus 1. It is the value of that polynomial for y is equals to 3 root 2. 18 minus 18 get cancelled, and here we get the value of this polynomial for y is equals to 3 root 2. That is the examples, or which is based on value of polynomials. Then you should solve the remaining examples from practice set 3.3 and practice set 3.4. In next lecture we will discuss about the few new concepts, that is remainder theorem and factor theorem of polynomials. Till you solve the examples from practice set 3.3 and 3.4. Thank you.